Hi, today I would like to show you the results of some of the remote sensing measurements we did in our semi-arid pine forest of the canopy temperature during the peak of drought. Now, this forest was planted in the middle of a shrubby, deserty environment, and it is subject to a very high solar radiation, and due to its low albedo and limited evaporation, the whole forest gets to a relatively high temperature. Now, as you know, stand density can affect temperature through the shading of neighboring trees or of the ground itself, but also the stand density affects the overall forest or plot albedo. And finally, convective cooling through wind penetration into the canopy layer can change the surface temperature. So the objective of this study was to assess the effect of stand density on the canopy and mean plot temperature. In terms of our methods, we used some long-term ecological research plots that were thinned to an even distribution in 2009, and they had a controlled density of 100, 200, and 300 trees per hectare. So we combined a number of already published ground measurements by Samir et al. In 2019 to remote sensing measurements that we did in summer 2019, and obviously focused on the thermal radiation measurements from the drone. All of this data was then processed using Pix4D and our custom tree recognition algorithms that were developed at the Weizmann Institute. In terms of results, in 2019, Samir et al. Already showed an increase in stem diameter and needle length through thinning, something that shows an additional growth. But this comes in contrast to our measurements on a Lidar system that didn't show an increased tree height or even canopy size. Now, additionally, our measurements show no difference in canopy to air temperature between the different treatments. Both of them remain within 5 degrees Celsius of the air temperature. And this highlights the ability of semi-arid forests to keep the canopy temperature close to the air temperature, which is essential for survival in this harsh environment. On a plot scale, as I already mentioned, the canopy temperature remained within about 5 degrees of air temperature, and that's the same for shaded soils. Now, for exposed soils, we saw temperatures reaching up to 70 degrees Celsius. And what this means is that plot scale means are typically affected by the stand density due to the fraction of exposed hot ground. Also, in low density treatments, the lack of shading and exposure to that hot ground meant about 30% more thermal radiation reaching the trees. But again, all the trees in the different plots and the different treatments seemed to dissipate energy equally efficiently, or at least to the same absolute temperature. What it means is that when we look at remote sensing data from satellites, for instance, large differences in surface temperatures would be seen between the different stand density treatments. But this is not necessarily a result of actual physiological differences, but rather one of canopy fraction. Now, canopy temperatures were shown to be about the same between all the different stand density treatments, and this could be simply a reason that all those different trees were able to dissipate the excess energy to the same level, and even in lower density treatments, increase in growth. Now, this energy exchange is obviously based on a canopy and leaf scale process or a set of processes that we still need to analyze in more detail in the future. Those dynamics, such as wind cooling, for example, could lead to different amount of cooling or overall also to a different radiation load. With that, I'm at the end of my presentation. Thank you very much.